So a cation, it is a positive ion because it has lost electrons. So an example is calcium 2 plus. If you ever want to make something an exponent in Cami, you just superscript right there. And then an anion is a negative ion because it has gained electrons. And an example, especially if you look at our periodic table of ions, whichever one you've zoomed in on, we could have oxygen 2 minus, O2 minus. Just make that a superscript. Okay. So reminder, this week, Monday and Thursday, are periods 1 through 4. Tuesday through Friday is periods 5 through 8. And Mr. Shumnu, Mr. Roman's office hours during 5th period, my 5th period link, and office hours today and Thursday. So if you didn't turn in your 1B slides from last week, Thursday, they were due last night by midnight. You should come to Monday office hours so that they can get turned in. Okay. So we're going to learn how to write the names and formulas for ionic substances using IUPAC rules. IUPAC is a worldwide organization. It's an association of scientists that determine what the standards are and how we name things so we can communicate with each other more easily. Okay. So names are very important, and being able to communicate across languages is difficult. So if somebody says hydrochloric acid, we all know what formula hydrochloric acid is, all right? So it doesn't matter how far we get today, you'll be able to start your homework that's due Wednesday by midnight. All right, so on here, I put this in the slide so we can come back and use it, but we're just gonna flip tabs. But I'm gonna draw, actually let me use my stylus. Let's see how well the stylus works. It's no worse than using my mouse. Okay, so we have our stairs. I guess technically it would come down here. All right, and then so your metals are this way. Your non-metals are this way. I write, oops. Yeah, see, it's not connecting to the drive. Oh. Okay. That was sloppy. And then just remember that hydrogen is really a nonmetal. Okay. And then if you are talking about group 1, the charge is a 1 plus. Oh, yeah, that's 2. It's 2 Oh, it's because I'm not using a fine point. Let's see if that helps. So a 1 plus, a 2 plus, 3 plus, this is going to be a 4 plus or minus. Just kidding, that is not a 5 plus. That should be a 3 minus. Oh, save failed. That's not good. At least we have a video. 3 minus. Remember my example of a negative ion or anion. I did oxygen and it was a 2 minus. Oop. What's up with me in numbers this morning? I think I'm just flustered. This is a 1 minus. Group 18 is 0. And then, oops. Charges for aluminum, zinc, and silver. So aluminum, zinc, and silver tend to have a single charge. On this periodic table, they show you the most common charges that you would normally see. So like here, there might only be 1 charge here and here, but those are just the most common charges for those elements, not all the possible charges, okay? So notice manganese is +2, +4, +5s. Cobalt also can be a +6. Like molybdenum is a +6. It's just the most common charge that we've found in nature. Okay, so if I go back here, pretty much these are the only 3 charges you would need to have memorized. But we have our handy dandy tables to help us. Just remember, not all periodic tables are labeled with charge. Okay, so I'm going to see if it lets, nope, still not let me save. Someone remind me at the very end to save what we've done, or we're all going to be crying. Okay, so using your labeled periodic table, if you can start typing in the chat the symbol, the charge for the different elements, I'll give you guys a few minutes to find those elements while I fix attendance. The video probably won't be posted till this afternoon because it'll need time to process on YouTube. There's something wrong. Boron, oops, I forgot. I know boron on the table doesn't look like it has a charge, but it should be a 3+. It's just because it doesn't form an ion often. And sodium is a plus. Just remember that plus means it's a +1. So when there's no number but a symbol, usually means 1. Oh, I put the charge in the wrong place, but 1+. Neon is Ne, and it has no symbol because it has a 0 charge. Lithium is Li. It also has a plus. If you just want to leave it as a plus or 1+, that's fine. Magnesium is a 2+. Sulfur is a 2-. Nitrogen is a 3-. And carbon is special. It could be a 4+ or minus. Okay. So let me zoom out just a teeny bit. Don't worry if you don't have answers, because I'll give you my copy whenever I can get my copy. So the biggest reason atoms forms bonds is because of the octet rule. So it usually wants to gain, lose, or share electrons, so it reaches 8. So that means they want to look like the noble gases. They want to have a full valence level. Helium won't reach 8. It only has 2 valence electrons, but it's completely full, and that's why it's in group 18. So it really wants this full valence level. And so they will keep gaining or losing. Today we're going to look mostly at gaining and losing. So if you gain, you're a negative ion, otherwise known as an anion. And if you lose electrons, you're a positive, positive ion, otherwise known as a cation. Okay. So, and hence my jokes. So here we have 4 protons and 3 electrons. So when you see that difference, it's a net positive charge. Here you have 4 protons and 5 electrons, so it's a net negative charge. So remember, cats have paws, so they're positive ions or cations. And onions are very similar to the spelling of anion. So anion are bad. They're negative. They make you cry. Okay, so our biggest point is ionic compounds tend to be a cation, which is, okay, that came out awful. I'm going to type this because I apparently can't draw on my screen easily. So ionic compounds are cations, which are normally metals, metals, and anions, which tend to be nonmetals or PAIs. So the reason I say PAIs is so on here, when you look at the table of polyatomic ions, I like to call, let's see, these are my that's my PAIs. So polyatomic ions. So all of these are ions, but these are my polyatomic ions because it's a many atom ion. And notice that the biggest list is negative. So they're most likely anions as a group, but there are 2 positive anions let me rephrase that. There are 2 polyatomic ions. Usually we only worry about ammonium, NH4. Okay. So here we want our neutral to mean that they're no charge. Okay, so the charge of all atoms must add up, or the famous word in math is sum up to 0. Okay, so when I am, hold on a second, I just need to rearrange these chords so I can write on my screen. Well, that's not what I meant to do. Oops. Okay. I have to write like this. It's really annoying. Hold on. Okay. So when I'm summing these at the bottom here, when I'm summing these charges, my mouse even showing up. Deep breath. So I'm going to do a +1 - 1 equals 0. So when they equal 0, this is balanced. I just rewrite it without the charges. This is a +2. This is a -2. That also equals 0. So this is balanced. So I just rewrite it without the charges. So when it's balanced, this is worse than learning how to write on a Promethean board the first time. You rewrite the symbols next to each other without the charges. Okay? And so when it's balanced, that means everything sums to 0. So here I have a +1, a -2 that does not equal 0. Okay, so we're going to learn on the next page how to fix that. This is a +2 and a -1 that is also does not equal 0. Right? So we're going to learn on the next page what we do when things don't equal 0. So the first step is always write the symbol for the ion, determine the charge for each ion, and then we're going to calculate the subscript. So this means we're going to see if it's balanced. So check if it sums write smaller, Miss Brown, 2, 0. Okay. So has anyone found lithium or bromide on this periodic table? So if it's written first, it's going to be on the left-hand side. It's most likely a metal. It's your cat. Woohoo! I'll be blurring some images out. Okay. And if it's a negative ion or anion, it's on this side usually. So for lithium, you want to look on this side and notice it's right there. It's a +1. So I'm going to draw Li. So this is my step 1. And then, did anyone find bromide? You want to look on the right-hand side. It's the second name. So we're looking over here, bromide. Notice there's nothing in group 18. They tend to not be in compounds. So I'm going to look over here. Nothing. Right there, bromide. It's a negative. That means it's a negative one. So that's my step 2, is to know their charges. So for step 2, I'm going to stop writing step. I have a +1 here. I have a -1 there. For step 3, I just want to know that my charges sum to 0. And if they do, then I'm going to rewrite the symbols next to each other. And that's my final answer as the formula. Okay. Then I just go to my next problem, the same thing. So strontium is the first name. So let me actually, so first name, maybe I can record an audio comment. So here. So the first name is always a cation. The second name is an anion. So when you're looking at the periodic table, the cations tend to be on the left and the anions tend to be on the right side of the periodic table of the steps. Okay. So did anyone find strontium yet? Okay, if not, that's fine. So we're going to look on our left. So strontium, 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 strontium. It's a 2+ charge. So when I go over here, remember step 1. Step 1 is to write SR and the charge underneath it, because that's step 2. So now I need to find nitride. So when I look on my left-hand side, if I look across, like if I look across, it's not helpful if the hand doesn't show up. I have boron, carbon, nitride. It is a -3. So N -3. So when I go to step 3, if I just look above, +2 -3 equals 0, that's the question I'm asking myself. And if no, then I'm going to start adding in the number of charges. So I'm going to add one of my positive ion and then see if that balances out, and just keep adding one of each type. So if I do +2, +2, and a -3. So I added one more strontium. That equals 0 now. This is a +4 -3, so no. If I do +2, +2, -3, -3, that's a +4 -6. That still doesn't equal 0. Okay, so we do a +2, +2, +2, -3, -3. I now have a +6, so this is really +6. This is -6, and it equals 0. So when I write my final answer, I'm going to have my subscript for strontium to add up to how many pluses I had to write down. So strontium is a 3 as a subscript because I needed 3 + 2s. Nitride, I have 2 minus 3, so its subscript is a 2. Okay, so I'm going to make another audio comment for subscript. So the subscript is the amount of atoms you have for each element in the formula or compound, and it tells you how many you have of that. So if you have 3 positive 2s, like we did for strontium, you write a small 3 to the bottom right in your formula. If you have 2 minus 3s, like we did for nitride, the subscript becomes a 2, and it's always written to the bottom right. So it's small, kind of like an exponent is small, but it's usually at the bottom right corner of the symbol. Okay, so we're going to do more practice, and then I'm going to teach you how to go backwards, and we'll see what you get done. Okay, so calcium, it's the first name, so it's on the left-hand side. So if I go here, it's right there, number 20. Calcium is a 2+. So I'm going to write calcium. I'm going to put it down as a +2. And now I need to find phosphide. So I'm going to go to my right-hand side of the periodic table and look for phosphide. And it's atomic number 15, P. It has a 3- charge. Okay. So these do not equal 0. So now if I do +2 + 2 minus 3 to see if it equals 0, the answer is still no. +2 + 2 minus 3 does not equal 0, still no. +2 + 2 + 2 minus 3 equals 0. Yes. So since I have 3 + 2s, I have Ca3P2. Okay. And then over here for magnesium, that's the first name, so it must be on the left. And if you look on the left, it's actually just above calcium, atomic number 12. So it has the same charge as calcium because they're in the same group. That is true most of the time. And then nitride, we just did nitride on the previous page, but you can look back on your periodic table. It's the second name, so it should be on the right. So when you find nitride, it's an N3-. So N3-. And once again, do they equal 0? No. But notice these charges. Notice these charges as close as I could get. These charges match annoying. Oh. These charges match these charges in the exact same order. So our final answer should have the same subscripts. Okay, so this should match my final answer here. So if you've already done the work, there's no sense in repeating the work as long as the charges are exactly in the same order as far as positive and negative. Okay. Now I just need to record. So the voice comment. So when you see Roman numerals written in, the Roman numeral tells you the charge on the metal or the cation, which is the first element or first name in the compound. So that is our way of realizing that some elements have multiple charges. So we can memorize groups 1, 2, 13 through 18, but some elements have multiple charges, which you can see on your periodic table of ions. So you usually don't go above 6 or 7, but there's always exceptions in chemistry. So that Roman numeral 3 means gold has a +3 charge. So when I find gold, and so what's great about the things that have positive charges, what's that? So notice here, the middle block, like groups 4 through 12, and even some into 14, 15, 16, they have certain elements with multiple charges. But really anything outside of group 1 and 2 that's a metal could have multiple charges. So we like to use our Roman numerals. So if you found gold, it's atomic number 79. The symbol is AU. And because that Roman numeral is there, its charge is a +3. Fluoride is on the right-hand side because it's a second name. That means it's an anion. And it's atomic number 9, so it has a -1 charge. So it's F, -1. So now if I check whether this equals 0, it doesn't, okay? But if I do like what I've been doing previously and just adding cation immediately, that's not going to help because I have more positives already. Than negatives. So I'm just going to add fluorines on until it matches my gold. So I'm just going to go back to 1 + 3. And if I add on another -1, that's still only -2. So that's not going to be enough to equal 0. So I need another fluorine. So then that sums to 0. That's a yes. So when I write this, AU would normally have a subscript of 1, but we're not going to record that it's a 1. If we had no gold, we wouldn't put it down. And then we have 3 -1s, so the subscript of fluorine is a 3. That's my final answer. Okay. And then for copper, 1 chloride. So copper, if you look here, it's in the middle. It's atomic number 29. So I have a copper and I have 1 Roman numeral, so its charge is a +1. And then chloride has to be on the right-hand side. So if I look for chloride, it's atomic number 17. Is a -1. And when I see if they sum to 0, it's yes. So I just rewrite them next to each other. And I'm done. Okay. So if you can take 4 minutes to do these 1, 2, 3, 4, 5, 6 problems, and then I'll go over answers. If you can, write them down, or just write down what the final answer would be on a piece of paper or in chat. Okay. So for 7, you should have gotten a final answer of K2O. Aluminum nitride should just be ALN. That is my L lowercase sometimes, or if you type it, it looks like that. Lead 4 sulfide. So if you did PB S, you should have gotten PBS2. Okay, so remember 1 lead is a +4 because of the Roman numeral, and 1 sulfur is a -2. So if you get another sulfur, you have a 0. So that's why the subscript of sulfur is 2. And then this should just be CoC. That's my E, not an I. And then this should be Fe2O3. And then this should be Li2Te. It's almost light, but you know, it's fake. It's fake light. All right. So, and if you need this one, so iron's a +3. So when you put 2 of them together, you get a +6. Oxygen's a -2. So we need 3 of them so that you end up with +6 -6 equals 0. Okay. So on the next slide, we're going to go backwards. So essentially, you always write, identify the positive and negative ion, and look for polyatomic ions. So remember, polyatomic ions are here. Okay. You need to highlight that box. Polyatomic ions are there. Okay. So we want to find our first symbol in all of these compounds are the cation. Oh, let me record that. So the first symbol in your formula is the cation. The second symbol is the anion. And the only other additional thing is if it is an element, an anion, you're going to write the name in IDE. So when you look at the periodic table of ions, you'll notice that the anion names don't exactly match the periodic table because they've already adjusted the ending for you to be IDE, okay, for most of them. So if we find Na, Na is the first name, so it has to be a cation. So you're going to look on the left-hand side, and you'll see that it's sodium. And you just write sodium. So the cation name doesn't change. And then Br, because it's the second element, must be on the left. And you'll notice that it's atomic number 35, and it tells you on the periodic table of ions that Br is called bromide as an anion. You do not have to worry about the charges or balancing them, okay? You just write the names of the symbols. So for Ca, we did Ca earlier, but it's also on the left-hand side. It's atomic number 20. So you don't have to worry about the charges. So it's calcium. But SO4 is more than one element. So we're going to look on our polyatomic ion list for SO4. And they're kind of alphabetical. If you notice, it is in the far right column. It says sulfate is SO4. You don't have to worry about Roman numerals right now. You don't have to worry about charges. It's just calcium sulfate. Okay. So K would be potassium. So over here, K is atomic number 19. That means sulfide is on the right-hand side. It's a single element. It's atomic number 16. So S is sulfide. Okay. And then we have Ba, atomic number 56, and O, which is atomic number 8. So we're going to write barium oxide. So oxygen becomes oxide. Okay. So if you can practice these, will remind me to review these answers at the beginning of next class. And then your homework is only writing formulas. It's not going backwards, I think. And here's more kind of working you through if you're confused. And then these two videos are on ionic naming. So these are ionic. And you can quiz yourself. And then we're going to learn how to write covalent compound naming. Okay, so as a reminder, Wednesday check-ins. If you want office hours, they're all the way at the top. Slide 2, I believe. Have a great afternoon. Be safe. Yep. Okay. I'm going to stop recording.